we can use the disk method to find the volume of solids of revolution, and these solids are formed by spinning a two-dimensional section, in this case a triangle, about an axis. So in general, if we have some curve defined by y equals f of x, then the radius of this disk is y, and therefore the area of the disk is pi by the radius squared. And then multiplying by the infinitesimal thickness of the disk, dx, gives the volume of this disk, and then we integrate from x equals a to x equals b to get the volume of the revolved solid. And you can imagine that this is going to be a cone. Now we can also revolve a two-dimensional region, in this case this region over here, about the y-axis. So in this case, the disk is going to have a radius of x, and this time the thickness of the disk would be dy. So that gives the volume of the disk, and then we integrate from y equals a to y equals b. And that gives us the volume of the solid. And the curve is typically given as y equals f of x. So you just solve for x to basically write x in terms of y. And you'll be able to evaluate that integral. Let's show the following equation describes the volume of a cone using the disk method. Well, given the cone has some radius and some height, and the radius somewhere along the height is defined as r, which is at some distance x from the apex. Then by similar triangles, we can write r on h is equal to r on x. And therefore r can be written as r on h multiplied by x. And that's the radius of any disk along the height. So multiplying pi by the radius squared, so that'll be r squared on h squared multiplied by x squared, gives the area of this disk, which can be visualized in the YZ plane. And assigning a thickness dx to this disk gives the volume of the disk. And then we integrate from x equals 0 to x equals h. And this gives the volume of the cone, which you can show evaluates to this result. Find the volume of the solid formed by revolving a region bounded by the parabola y equals 2 and the y-axis, so this region in 2 dimensions being revolved around the y-axis. So therefore the radius of any one of those disks is x, and then pi by x squared gives the area of the disk, and then we assign a disk a thickness in the y direction, which is dy. And that gives the volume of the disk, and then we integrate from y equals 0 to y equals 2, and that gives the volume of the solid. So now you can substitute for x squared from this equation, and you'll be able to find the volume of that solid. Now we can use the disk method to find the volume of a revolved solid that's obtained by spinning or revolving a two-dimensional section about an arbitrary horizontal or vertical axis. So in this case, the distance to the axis will denote d, and we'll denote the distance from the horizontal axis to the curve as y, where y is equal to f of x, which describes an arbitrary curve. So therefore, the radius of this disk is d plus y, and squaring that and multiplying by pi gives the area of the disk. And then assigning the disk a thickness dx, will give the volume of the disk, and then we integrate from x equals a to b to give the volume of the solid. But as we can see, the middle cylinder is hollow, so we need to subtract this volume from the volume of the solid, because we're revolving this triangle about this horizontal axis. So the volume of this cylinder is pi by the radius squared, which is the area of the cylinder, multiplied by b minus a. And that gives the volume of the revolved solid. So you'll see that using the disk method is not always ideal, and we'll learn other methods as we go along. Let's find the volume of the solid formed by revolving this region around the horizontal axis, passing through y equals minus 1. And to do that, we're going to use the disk method. Well, the radius of the disk is 1 plus y, and then squaring that and multiplying by pi gives the area of the disk. And assigning a disk an infinitesimal thickness in the horizontal direction gives the volume of the disk. And then we integrate from x equals 0 to x equals 1, which gives the volume of the entire solid. But we have a hollow section in the middle, so what we're going to do is simply subtract the volume of that cylinder in the middle. So that will be pi by the radius of the cylinder squared, and then multiply by the height of the cylinder, which is 1. And now you can substitute for y from this equation, evaluate the integral, and find the volume of the solid.